Hey folks, my name is Sydney. I'm an open source engineer at LangChain, and today I'm super excited to talk about how you can use RLMs with deep agents. First off, what are RLMs? An RLM is a recursive language model, which simply means a model that can call itself. So if we think about agents, we often define agents in code, and so the orchestration for recursive language models actually lives in code. You give the main agent and model the power to write code to recursively call itself. And this means that context can live in variables or files rather than just in the direct context window of the model. And this broadly enables a super flexible divide and conquer strategy for work. Let's talk a little bit more about why you would want to use recursive language models. Agents have trouble doing work reliably at scale. If you give your agent a file with thousands of lines, it's going to have a really hard time kind of deterministically processing that file. In addition, context windows are finite, and so over long conversations, we have to summarize, right? But summarization is lossy. And so if you give your agents the power to orchestrate work through code, you can avoid these problems. RLMs support, as I mentioned, deterministic coverage, which is great for data problems at scale. They also support bespoke orchestration. So you can organize work with code-like primitives, right? So loops, fan-out and pipelining, sort of any code-like primitive you can imagine. Okay, so let's talk about how RLMs are supported in deep agents. As a reminder, deep agents is an open source harness for building general purpose agents that are built for complex real-world tasks. So here's kind of a look at how RLMs are implemented. First, we have our main agent, which we give access to a code interpreter. We mentioned that the orchestration for RLMs lives in code. And so the code interpreter is this lightweight surface we can give to our model to be able to write and execute code without being as heavy-handed as needing to attach a sandbox. So in order to use RLMs, we give the main agent access to this task function in the code interpreter. So the main agent writes code that uses this task function. It calls out to subagents, and then there can also be other code surrounding these task calls. So maybe data preparation, maybe after all the task calls, aggregation, things like that. All right, so how can you get started using this with deep agents? It's pretty simple. You just use the create deep agent primitive, and then you pass this code interpreter middleware to enable code mode. All right, let's test this out with dcode, which is our terminal coding agent built on top of the deep agents harness. We can start it up by typing dcode. One key thing to note here is that to trigger RLM usage in deep agents, you can use the workflow keyword. So here I'm asking dcode to run a workflow to generate 16 haikus about breakfast food and use a tournament setup to determine the best one. So we've got 16 subagents just generated haikus pretty rapidly. Now we're on to the round of 16. Great, so we can see the model is writing code. It's calling this JS eval tool. We're already off to the quarterfinals. Looks like the model wrote some bad code, but it's now correcting itself. And then off to the finals. So we can see tournament complete. I ran a full haiku tournament, and then the winning haiku is about berries. Crimson berries glow, morning sweetness melts on tongue, summer's gift awaits. I actually just bought some blackberries from the farmer's market, so this feels on brand. Great, so let's talk about a little bit more of a concrete example here. So one way that we tested the effectiveness of RLMs is with the Oolong dataset, which is a dataset that challenges models over long context reasoning and data aggregation tasks. So I'll talk a little bit about the Oolong dataset setup, and then I'll showcase some of our experiments. So the agnews portion of the Oolong dataset is structured as a table with thousands and thousands of rows, where you have a date, a user, and then a news headline with no label provided. And we give models the challenges of classifying each of the headlines according to 4 categories: world, sports, science and tech, and business. Then we ask distributional questions about the data. So these can fall under 3 categories, and moving from kind of easiest to hardest. First, we have counting. So an example here is like, which label is the rarest among the headlines? Secondarily, we have the user category. So this requires the problem solver to filter and then count. So for example, for user 72341, how many science and tech headlines are there? And then the most difficult is the temporal reasoning tasks. So for example, before August 2004, was sports more common than world in the headlines? And so the reason that this dataset is challenging is that there's so much data. And so it's pretty hard for a model to be sent thousands and thousands of rows and then perform these reasoning and data aggregation tasks without the support of RLMs or some sort of coding support. Okay, so the first traces we're going to look at here are comparing deep agents with no code interpreter with deep agents enabling a code interpreter. So you can see at the 64K context length, there's actually not a huge difference between the plain deep agent shown in green and the deep agent with RLM support enabled via the code interpreter, here shown in pink. But now, if we look at a context length of 128,000 tokens, we can see that the RLM-enabled deep agent does much better. One trade-off here is that the latency for the RLM-enabled deep agent is definitely slower, and we do see token costs higher at this rate. Although generally, I do think if we optimize further, maybe design some skills explaining how to approach this specific problem, we could cut the token count and cost down significantly. So you'll note here, you can see actually in the plain deep agent, there's a lot of answers that look kind of like, I can't answer exactly, or I'm blocked from computing this. The model is actually like giving up early on this task because it's so overwhelmed by the context. So you can imagine if the context length was even longer or the problem was even more challenging, that the agent with RLMs enabled would continue to outperform the plain deep agent. We think RLMs are a super powerful primitive, and that's why we're so excited to expose them in deep agents. Let us know what you think.